So we're here with David Muehsam, and David's one of the speakers that we've been here with at the New Paradigm in Physics conference in Bagni de Lucca. And David, when you spoke yesterday, the thing that most struck me was the connection between your yogic practice and your work. Can you speak a bit about, you said you started to practice yoga when you were a child.
Well, I first practiced meditation when I was 14. I took a course in transcendental meditation. They gave me a mantra, and so on and so forth. And so there was some exposure there. I feel like I was too young at the time to fully appreciate it, but I stumbled into this path and then began to practice yoga 4 years later or so. So I think that yoga and meditation have informed my point of view scientifically, but I also feel quite strongly that the spiritual satisfaction needs to come from those practices, not from the results of the science. So I'm not on a mission to prove that there's a spiritual world or that the soul exists through science. I actually strive to maintain some boundary between my own personal spiritual views and the results of the science.
But you don't take your identity from your work as a scientist.
That's exactly what I'm saying.
Yeah.
I feel like with science, it's very important that we be willing to say, I was wrong. It's very important to be open-minded to other ideas, even if there are ideas that we don't like.
Interesting.
Yeah.
So what, as a 14-year-old, what was it inside of you that drew you toward what was essentially a spiritual practice? I mean, my understanding is that part of the brain is not even developed at the age of 14. So
probably it wasn't in me either.
So what was the catalyst?
As a kid growing up in New Jersey, this was something that was grounding for me. It helped me, as a troubled youth, not particularly troubled, but as someone struggling to grow up in America, meditation was in the zeitgeist at the time. I had the opportunity to learn a little bit of it. I feel blessed to have come across that. I think it's really remarkable the time that we live in, how much access to information we have.
It's extraordinary.
Whether it's spiritual instruction or scientific information, experience of the arts, knowledge of history, knowledge of so many things. I'm just a kid from New Jersey, yet in previous ages to have had the opportunities that I had, you'd have to be born into the nobility or the priesthood or some kind of special class, and I wasn't. So I think this is a remarkable time for that reason, how much access we have to ideas, to other points of view. And so growing up in New Jersey in the shadow of the 1960s, these ideas were around. People were practicing yoga, they were practicing meditation. I could read the Tao of Physics and go, wow, what's that about? And I was curious.
And so do the questions that you're asking in your research enter your meditation practice? And do you find information there that informs your scientific practice?
Well, I think certainly there's a very strong connection between any kind of mindfulness practice and creativity, and scientific creativity certainly is informed. I'll be sitting there doing my practice and a thought will pop in. And maybe it's about the fact that I've got to pay my taxes. But often it's related to something scientific. There's so many instances of scientists reporting that they solved a problem. Poincaré, for example, had an insight about Fuchsian functions in the hyperbolic plane while he was getting onto a bus with a friend. And his claim is that he was certain that this was the way the solution worked at that moment, and it just appeared. Lots and lots of people will say, well, I was in the shower and I had this idea, and let me share it with you. So I don't think a formal meditation practice is necessary to have these kinds of moments of intuition. The mind is always working, it's always assembling ideas. I think that meditation practices can be helpful to create a fertile ground for that. and that there's a very deep connection between mindfulness practices and creativity. And we see many, many artists saying the same thing. I see jazz musicians nowadays who are practicing meditation, using these types of practices to get to that place, to get to that zone where they feel that they're creative, that they're inspired, that they have access to information. So this is very, very exciting, but I wouldn't say that meditation as such is necessary to have this experience.
Right. In your work, is there a central question that you began to ask that drives your work?
I don't know if it's a central question. I think there's a central fascination. Certainly when I started to work in bioelectromagnetics 25 years ago, we had discovered fairly recently that weak electromagnetic fields could repair bone, for example, that they had a wide variety of biological effects like increasing oxygen, blood flow in the body, and we were beginning to understand that different frequencies and different amplitudes had different effects. So we thought, well, perhaps there's some structure there. Perhaps there's a Rosetta Stone that we can use to decode the language of life using electromagnetic fields. So there was a tremendous open field at the time. And I think subsequently we discovered that nature is tricky. And it's not so much as ascribing a single frequency to the liver or to the spleen, or just finding that signal. It seems like the whole situation is more complex than I thought it was when I was a young man out of university.
So your questions just bred more questions.
Yes, and for example, Giuseppe Vitiello in the lecture that we just saw made a wonderful point, which is that there's a lot more that we don't know, that we don't understand than what we do. And as scientists, of course, we have a tendency to talk about what we know. It gets us funding, it gets us jobs, it keeps us employed. But it's certainly in the study of consciousness and in the study of bioelectromagnetics, how that relates to molecular biology and biological regulation, there's a great deal that's being discovered now. For example, if you look at the papers that are coming out having to do with, let's say, enzyme function or the structure of olfactory receptors. Today, we're learning new things all the time. It's an incredibly exciting time for science. And this is not just in the study of consciousness, but even in the mainstream, where we have new ways of looking at things. We have so many researchers. We have such a tremendous information stream that we all have access to now, that the growth of ideas seems to be accelerating. There's a tremendous amount of access at this time.
There's an interesting aspect of worldwide community also being utilized in the science field right now. I know in enzyme folding, for example, there was a game that was created because humans could compute this differently than computers. Were you aware of that project?
I don't know the details of that project exactly, but certainly one of the interesting aspects of the human mind is the way that it works differently from a computer.
Right.
For example, if I ask you if you know Jacob Seymour, you don't need to search every memory in your memory bank in order to determine if there's an entry for Jacob Seymour.
Right.
We know more or less immediately if we know Jacob Seymour. I just made up the name.
Right.
I'm
searching my memory banks. I'm going,
named Jacob Seymour. Or we know more or less immediately if we're not sure, even.
Right.
But we don't have to scan through the sum total of every memory in our life to see if there's a flag for that name. So there's a holistic way that the mind works that is fascinating and it seems to defy what we understand about computing. We'd like to think that maybe massively parallel computing could mimic that. But there would be some limits to computation at that level. Now, of course, there's a tremendous amount of talk about quantum computing, and there are large-scale research interests by some major corporate entities in quantum computing. And it may be that the mind works like a quantum computer to some degree. It may also be that the concept of a quantum computer is our new hammer, and when all you've got is a hammer, everything looks like a nail.
Oh. I think that's a good point. We've had a lot of discussion about that over this weekend.
Yes.
So I'm very interested in how your work actually informs your personal life, how you move through the world. Is there a correlation in terms of how you approach reality based on the study that you're doing?
Well, I think one of the main themes that comes out of how my work informs my personal life is that in order to understand, for example, my work in bioelectromagnetics or the applications to neuroscience, one has to take a transdisciplinary perspective. We have to work with neuroscientists, with biologists. Ultimately, this relates to behavior, has social implications, relates to life in a much larger way. So one of the things that I've understood through my scientific work is how important it is to listen to other people and to people in other specialities that have different points of view from myself. This idea that we can achieve full knowledge from one branch of the sciences, or even from my own individual point of view. I need to listen to your perspective, to learn and to try to synthesize from all of the different perspectives as best I can. We're finding more and more that these fields of bioelectromagnetics, neuroscience, psychoneuroimmunology are deeply interrelated. And we're all specialists in one way or the other. So it's so important, as we have at this conference, specialists in different fields coming together to share their ideas so that we can synthesize something new.
And is this kind of openness common in the academic world? My sense is that it's been very siloed in terms of research in the academic world. Are we entering a new phase where there's something different happening?
I think so. I think silos are not necessarily bad things. Silos allow us to generate deep knowledge in specific fields, and that's necessary for moving forward as well. But I do see more and more interdisciplinary conferences on consciousness. Those that are studying immune response, for example, the molecular mechanisms, their psychological effects. I think we're entering into a time of more interdisciplinary or transdisciplinary research, but we need the silos too. They both are a part of the whole.
We're living in, I think, what's a very, very specific time, and we speak about this idea of a shift in consciousness. Yeah. Do you have a sense of that through your work, or is that your meditation practice? What's your sense of this shift that we're in and what it is?
I don't even know where to start to answer that question. I think clearly we, on a basic level, we're all much more interconnected or aware of our interconnections than ever before. If you have a friend in Hong Kong, you can call them up anytime. So the spatial distance between us seems to be shrinking in some sense. Our ability to communicate with one another is much greater, and it's much easier to do that than it ever has been before. So clearly from that, there's a much greater sense of global consciousness when an event occurs somewhere on Earth. If it's something that is important to people, it's splashed across the internet immediately, within minutes. So there's a much greater sense of us all being connected and sharing this planet together than I think ever before. And of course that brings some blessings and brings some difficulties. In the sciences, I think there's an increased interest in the study of consciousness itself. And I'm seeing more and more papers coming out that pertain to this and are grappling with many of the difficult questions of consciousness. What do we mean by consciousness? Where is it located? How does it work? All of these questions are being pondered on this global academic intellectual stage. And at the same time, we're beginning to see more and more technologies where we can measure heart rate variability or a galvanometric skin response. We have much better capacity to analyze data from brain waves, for example, or regions of brain activity and how those correspond to stress, to meditation, to different states of consciousness. So we're learning a great deal at this time. And in a sense, this rate at which we're gathering knowledge is growing and growing and growing and growing. Whether that makes me any wiser, I don't know. But certainly it's moving the sciences forward very, very quickly. And the science of consciousness studies is something that seems to be coming to the fore at this time. There are conferences all over the world on consciousness studies, composed of serious academics. We're also seeing more and more interaction between meditation practitioners and scientists. For example, the Dalai Lama every 2 years, as you may know, convenes a conference.
Right.
He's been working with Francisco Varela and company.
Have you been to that conference?
No, I'd love to go to that one.
Wow.
I'd be very, very interested in that.
Do you think, do we have the tools within the science community to study consciousness?
Well, now this is an excellent question. If consciousness can be studied objectively, then perhaps we do. But I think there are many, many arguments that there's a subjective element to the study of consciousness, and that the meditative traditions provide a means of clearing the lens, for example, making a clearer view of our own consciousness, to be able to explore or inquire about the nature of consciousness directly. And this, of course, was one of the things that led me to meditation and yoga when I was younger. I wanted to have the direct experience somehow. I wanted to learn something more about myself. And I wasn't finding those answers in the sciences. Now I think we're going beyond this idea that somehow the internal practices and the external practices are separate. We're beginning to see that perhaps they're complementary. Menas Kafatos, a quantum physicist who's done quite a bit of work in the field of consciousness, talks about object-based science. And object-based science is the science of machines and the science that we're used to, where we study the external world.
Right.
And then a subject-based science is a study of the internal world. And for example, the Tibetans have a very sophisticated archaeology or cartography of the internal world, and many methods that they use to explore that. And Kafatos speaks about object-based science and subject-based science as being complementary to one another. Not that one is better than the other,
Right.
but the two form a whole. And so I like to look at it that way. Say, okay, we don't have to find everything from one or the other, but we use all the resources at our disposal.
And would your field of research be object-based or subject-based, or a combination of the two?
It's hard to say. If I write a paper on a mathematical model in bioelectromagnetics, that this is an object-based type of research, but it may have relevance to a subject-based practice. So what I find interesting is the interplay between those things. It may be that, like with waves and particles, the idea of the complementarity between waves and particles has to do with how we look at them. When we seek to detect particles using a particle detector, we see particles. When we seek to observe waves by looking at interference patterns, for example, what we see are waves. So this notion that a subject-based science and an object-based science are somehow at odds with one another, or somehow mutually incommensurable, may not be sensible. And this is where the idea of complementarity comes in. Yin and yang, male and female, light and dark. These are defined by each other.
If we're here speaking about a new paradigm in physics, what's your vision of what science looks like in this new paradigm?
Well, I think the new paradigm in physics per se has been written and spoken about for a long time by many people much brighter than I am. So I don't feel that I need to comment so much on that. What I find really interesting in my career is the applications to biology. And that we're discovering, for example, the human biological system, the nervous system, is very, very sensitive to electromagnetic fields. the very, very small energies are involved in the transduction of some of these fields. They're non-thermal, for example. They're not heating the brain and thus causing us to have a different kind of thought. But this notion that the very, very weak energies, or what some people might call subtle energies, can have large biological influence, that these could affect health outcomes. That these could be related to stress, to anxiety, to well-being, could be related to healing, that have relevance to our consciousness. This I find fascinating. So for me, it's not so much the revolution in physics, because in some sense this occurred in 1924 with the Copenhagen interpretation of quantum mechanics, or many of the other great steps forward in modern physics. But what we're seeing now is more and more application to biology. For example, if we spoke yesterday a little bit about the idea that some biological molecules might best be thought of as existing in superposition states between different functions. Enzymology, the function of hemoglobin perhaps, a number of examples come to mind. Do we need to understand quantum mechanics to have a better feeling for these behaviors? Are we observing quantum behaviors in the body with these types of examples that we're coming across? So when we talk about quantum mechanics in enzymology and tunneling, for example, or the extraordinary sensitivity of the receptors in the eye, or the wave nature of olfaction, these aspects of quantum biology, are they telling us something about consciousness? And so I'm not so much interested in the revolution in physics telling us about that. But I think that the social impact and the scientific impact will probably come from when we observe these things in the body. And perhaps when we learn how to heal the body using some of these principles. Generally speaking, nature makes use of what nature can. And we're understanding more and more and more how electric potentials and ion gradients, and of course the nervous system is inherently electrical. We could understand a lot of this using classical physics, but again, if nature makes use of everything that she can, then it stands to reason that nature is taking advantage of quantum phenomena as well. And so the study of these things may shed light on our notions of consciousness, may help us to understand ourselves better as well.
So do you think then the biological application will be the translation of this physics into something that has a social application or an accessibility?
I think so. I think that the discoveries made in particle accelerators are extremely important, and they often have great ontological significance. But I think in terms of the social impact and the impact on healthcare, perhaps, it's the application to biology where most people will find things more meaningful. For example, if our brainwaves really do come into some kind of coherence through our communication, whether it's simply by the virtue of the words creating certain types of thoughts that have similar brainwave patterns, or if there's some kind of electromagnetic communication or quantum entanglement occurring, this is telling us that we're connected. It's allowing me to understand that by speaking with you, I'm changing you. To understand that your thoughts and your ideas are somehow being shared inside my mind, that physically I'm separate from you. But when we go to the level of the thoughts that we're sharing the same thoughts somehow. We're more connected. This sense of being separate becomes more illusory.
I'm a storyteller, so what's interesting to me is I'm at this conference with people who have an extraordinary ability to articulate their research, but most of that research is not so accessible for what might be a mainstream population. So my role is how do we story this in a way that this important information can become accessible for a broader audience, if that makes sense. And I'm very much a layperson here, with the privilege of being a fly on the wall in this think tank. So,
well, my sense of that, a lot of it is to make some translation, that this transdisciplinary aspect of what we're doing is really essential to making it meaningful to the world. It's so very easy to sit in our ivory towers and have wonderful ideas and over a decent bottle of wine congratulate ourselves about how pleasant, how clever we are.
But we are in a shift. We're in a shift, this shift, so. And the coalescence of idea and the ability, what we were speaking about, this idea of our thought waves coming into some sort of resonance with each other. If that can happen on a much broader level, then what is the human potential right now?
Certainly, and what are the ethical implications of that as well? If my thought waves are affecting your thought waves, then I need to begin to take some responsibility for how I use my thought waves.
Well, this is another interesting aspect. I mean, part of what drew me to physics was an experiment going on in the Atlas project in CERN, and the fact that in their having to story their research to make it accessible for a mainstream population, they were finding their research results were changing. And then they also found that they could control the essentially particles at the quantum level using narrative, and specifically poetry was having the clearest effect. I'm a writer, so I've always known that what I write affects reality. But suddenly we're getting hardcore science saying narrative creates reality. That has an implication. What are the stories that we're telling right now? You know, and what's the ethical implication of the stories that we're telling right now?
Well, these are important questions. And for example, when we're looking at changes in gene expression that are induced by electromagnetic fields or mechanical vibration, we may be able to say, oh, okay, this corresponds to inflammation, or these changes correspond to a movement towards a gene expression for a stem cell becoming a cardiomyocyte, this kind of thing. However, the deeper meaning, there may be so many genes involved that nature is laughing at us quantitatively. And so it may be that our minds work in narrative. So of course it's natural for us to see the physicists at CERN using narrative with their particles. Because this is the way we extract meaning as well. So the story kind of goes in 360 degrees then. It reflects back upon ourselves in terms of what we find meaningful. We're seeing that there's so much complexity in biology today that it can be difficult to understand which molecules are regulating which. When we have negative feedback and feed-forward loops, molecules that are engaged in cycles of regulation, it's hard to say who is the slave and who is the master. And so we're beginning to understand that things are deeply intertwined, interconnected. And one of the things that I think is really relevant for our life today is that we're discovering that we're very sensitive to our environment. And when a human being is placed in an environment where they feel comfortable, where they don't feel fear, they relax. This has an effect on their health. Of course it has an effect on how they interact with other human beings. So I think one of the really deep implications of the work we're doing is how can we make better environments where people can live more harmoniously? How can we be better stewards of the earth to create a more harmonious natural environment that is sustainable for all forms of life? And these are questions that really come to the fore. If we're all interacting, if I'm affecting you through my actions and my thoughts, how can I make life better for you? I have a responsibility if we're all connected together in a global system.
Now you're speaking, I think, about something that's very close to my heart, which is the idea of community. And community as a place for the kind of healing that's necessary now. You know, I think there's an interesting study that could happen around what happens on the biological level when a group of people live together.
And when they live together in harmony.
Exactly,
What is it that's happening?
Yes.
Are we seeing changes in their immune response? Is it somehow healthier?
No.
Is it less stressful? this kind of harmony. Steve Cole and his group at UCLA have done some wonderful research on psychosocial stress and inflammation and glucocorticoid receptor response, immune response in the body, and showing that greater psychosocial stress is corresponding to greater inflammation in the body and a decreased immune response. So if we can live in harmony with one another, there's evidence that this allows us to be more healthy physically as well. So this new science is not necessarily all based upon invisible forces and quantum correlations and spirit matter and all these sort of transcendent ideas, which are lovely to talk about. But there are many aspects that have been demonstrated in what most of us would consider conventional biology. And so the tools of modern biology are proving to show us also that we're all connected, that our environment is important, that the way that we interact with one another is important for everyone's health and for everyone's well-being.
Well, I think that's a great note to end this interview on, but I really appreciate you taking the time to speak with us.
I did okay.
Oh, you did fine. No, you did great.
You asked the greatest questions. Thank you.
Thank you.
Yeah.
I want to ask you one last question.
Sure.
So we're both expats. So I mean, we're both living not in our country of birth.
Yeah.
And I'm just curious, what was the inspiration for you to decide to end up in Italy?
I don't know. I think it's not so much by choice as by chance. I think I've always had it in my stars to travel a lot. I've lived in a lot of different parts of the world. I've had the great fortune to work quite a bit in Asia, and in China, and in India, and in Indonesia, and Australia.
But you ended up in Italy.
Yeah, I wound up in Italy. I love Italy.
We do too.
And both my parents were European, so I grew up in a European household. So that certainly had an impact, because inside the house it was Europe.
Right.
Outside the house it was America. So I don't think it's so simple as just trying to go home to my childhood home. Yeah. But the points of reference for me, personally, were there. And I love going back to America as well. But at this point in my life, I'm really happy over here.
Great.
Yeah, so I don't know what comes next.
Okay. Thank you.
Thank you so much.
Yeah.
Great question.